not college algebra. Hello, trigonometry, and this is going to be part 2 of 8.1, the law of sines and the law of cosines. So, before we begin, I gotta press the hide button on this. Okay. All right, so, pretty sure it's still recording, right? Yes. Yep, okay, we're still good. Sorry about that. All right, so before we begin, just want to make sure that you have your calculator. You're going to need it. Again, if you need to use the calculator we've been using, again, just go to eeweb.com/tool/calculator, and this will give you all the tools you need. Again, make sure that your calculator is set into degrees. And just so you know, the things we'll be using today is cosine, like cosine of 75. We'll also be using cosine inverse. So, and also cosine inverse, say, previous answer. I'll take the previous answer, plug it in, and do that. Something else you also have to keep in mind is that we will be doing square root. So make sure you use the square root value, and of course, previous answer. That's going to be, the previous answer button is going to be really helpful. So those will be the things you'll be using for your calculator. I won't be using the eWeb calculator too much because I got a handy calculator with me, but you can use this one to double check all the work that I'm doing. So with that said, a calculator is all you need. You don't need a unit circle, you don't need a formula sheet. So let's begin. So let's say I give you this triangle and you're given the angle B along with little c and little a. So that tells me we need to find big B, we need to find big B and big C, and also we're going to need to find little b. Now, yesterday we learned about the law of sines, and the law of sines says as long as you have a pair, a big B and a little b, big A, big C, little c, as long as you have a pair, we can do law of sines. But here's the thing. I can't use the B's, I can't use the C's, and I can't use the A's. Shoot, I don't have a pair. And if I don't have a pair, then sadly I cannot use the law of sines. I can't do sine of A over little a equals sine of big B over little b, etc., etc. Sadly, I cannot use this if I don't have a pair of A's, a pair of B's, or a pair of C's. So what are we going to do? How are we going to solve this if we don't have a pair? Well, it turns out when you don't have a pair, that's when you have to go to the second law, or the law of cosines. And the law of cosines is on the next slide. And the law of cosines is not as pretty as what we worked with yesterday. And just so you know, you're probably thinking, oh, I got to memorize 3 formulas for the law of cosine? That's what it looks like. But I just want to point out, these 3 formulas actually mean the same thing. Think about it. For this one, you got a squared over here, little a, where angle A is on the other side. Here, it's just little b with big B. Here, it's just little c with big C. They're basically rearranged the same way, just according to what letter you use. And also, realize that whatever letter is out here, the other 2 letters, or for the other 2 letters, will be in the formula. So if I have little b here, that means in the equation, I'm going to have to use the other 2, little a and little c. Same thing here. If the little c is on the outside, on the left, that means on the right, I'll have to use AB. Basically, these 3 formulas mean the same thing. It just depends on what letter you're using. So, and usually, the one you want to pick, or the variation you want to use, that will depend on the angle that you're given. So if you're given angle A, you might want to use this one. If you're given an angle that's B, you might want to use this one, so on and so forth. So keep these handy. And if you're not sure how to memorize them yet, keep referring to this. It's already in your notes. It's already in the slides. So there you go. And also, please get into the habit of using the brackets around the first part and around the second part. If you don't use brackets between the two parts that are being subtracted, your chances of making a mathematical error are extremely high. Please, 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 please put brackets around those two parts. Trust me, I've been teaching this class for 5+ years now. Trust me. Okay, so enough about that. Let's show you how to use it. So let's say we have these three parts that we talked about, like you have big B here, little c, little a. Again, you see no pair. And when there's no pair, that means you got to do the law of cosine. And now our cue is that we have this angle. We have big B as our angle. So let's use big B to find its pair. We're going to find out what little b is. Or in other words, look back to the formula. Since we're given big B, let's use this variant of the law of cosines. So in other words, we're going to have little b squared equal to all of this. So let's do it. Let's use that variant. Okay, just going to put a star next to that. That's the one we're going to use. Okay, I'm going to go ahead and just copy it down real quick. I'm going to copy down the law of cosines just so you can see what I'm working with. So like we said, we're going to use the second variant of the law of cosines. So b squared, that's going to be equal to a squared plus c squared, using the other two letters we haven't used yet. Again, close brackets. And then minus 2 times a times c, and we're going to times that by cosine of big B. Again, I'm literally just copying down the formula from the previous slide, just so you guys can easily see it on this example. All right, so this is the law of cosine formula we're going to work with. Now, let's plug in what we got. So we don't got little b yet. I do have little a, which is going to be 3. So that's going to be 3 squared plus c squared, where c is 4. And again, just be safe. Keep those brackets around it. And then minus brackets. We'll go ahead and do 2, and then times a, where a is 3, and then times c, where c is 4, and then times cosine of big B, where big B is 75 degrees. Okay? Okay, now we got the numbers plugged in. Now let's do some chugging. Okay, just going to go ahead and put my brackets up while I'm at it. Okay, so I'm going to be using my calculator. You guys can use your calculator, and let's check. So first, we're going to have 3 squared, which is 9, and then 4 squared, which should give you 16, and then we're going to minus that by what's in red. If we do 2 times 3 times 4, 2 times 3 is 6 times 4, that should give you 24, and then times cosine of 75. Okay, let's simplify a little bit more. Going to the next step. There we go. 3 squared. Again, keeping the brackets. Green, red. Okay. So then here in the green, we'll do 9 plus 16, which should give you 25. And then subtract that from the red. And in the red, we got to do 24 times cosine of 75. Making sure your calculator's in degrees, press enter. And you're going to get a big decimal. And please use the entire decimal. So 6.211657082. That's what you get when you do 24 times cosine of 75. All right. So now all that's left to do is you got to do 25 minus that decimal. And if you do 25 minus that decimal, or in this case, you can do 25 minus previous answer, or ANS, which makes it so much easier to do. Minus previous answer. You should get this. And once you get here, we're almost done. Remember, this isn't our final answer yet. B, we want little b, not little b squared. We're going to have to take care of that square, and you probably already guessed, by taking the root. So now, in your calculator, you'll do root of previous answer. If you do that, you'll get your b, or your little b. So the square root of 18.788 blah blah, or square root of previous answer, and you should get 4.335. Now that we have our final answer, now you can round. And just like the previous video, you'll round to, for these examples, you'll round to 3 decimal places unless told otherwise. So for little b, it's going to be 4.335. Okay, so that was just an example of how you should properly use the law of cosines. Now that you've had your introduction to the law of cosines, now let's go to a full-length example that you'll see on the Hawks program. Okay, real quick, I gotta fix this. Perfect, right where it needs to be. So, find the remaining angles and the side of this triangle. So, let's see what we got. First, we got an angle A, which is 100 degrees, but we need a B and a C. So, over here, we're going to find big B and we're going to find big C. And in terms of the sides, they give us that little b is 4 and little c is 2. But they do not give us little a. So we're going to have to find little a. And sure enough, if you look at what we're given, we have no pair. And if we don't have a pair, that means we can't use the law of sines. We got to use the law of cosines. All right, so, but which variant of the law of cosine should I use? Well, let's look at the angle we're given. We're given angle A. So, look back to the law of cosines, look at what has angle A, and that's the one we'll use. So, we'll use the first variant this time. A squared equals B squared plus C squared, so on and so forth. I'm going to go ahead and copy that down. I'm going to go ahead and copy that first variant down just so you can see it for this example. Okay, so then 2BC times cosine of big A. Okay, just going to double check. A squared, B squared, C squared minus 2BC cosine A. Okay, that's the one we're going to use. All right, so now let's plug the numbers in. Go ahead and use my brackets. Okay, ready to go? So first, I'm going to have B squared, which would be is 4. So that's going to be 4 squared. C squared, where C is 2, is going to be 2 squared. Then subtract that from 2 times B, where B is 4, times C, where C is 2, and then times cosine of big A, where big A is 100 degrees. All right, everything's plugged in. Let's do the chugging. So A squared, again, I'm going to put my brackets up again. Okay, so here we're going to have 4 squared plus 2 squared. 4 squared is 16, plus 2 squared, which is 4. I'm still going to subtract that from all of this. 2 times 4 is 8 times 2, and that's going to give you 16 times cosine of 100 degrees. All right, we're getting closer to where we need to be. So a squared. Okay, brackets one more time. Okay, so first in the green bracket, 16 plus 4 is going to be 20. And then in the red bracket, we got to do 16 times cosine of 100 degrees. So 16 times cosine of 100 degrees. If you plug that in the calculator, you should get this long decimal. Minus there. So in the red, we should have negative 2.778370843. Again, use that whole thing. So now, we got to do 20 minus that negative. If you want to change that to plus positive, you can, however you do it. But you do the math, 20 minus a negative or 20 plus positive, and you should get this. You should get this, 22.77837084. And that is a squared. We're not done yet because we just want little a. We don't want the square. So to solve it, take the root. So and then after you, that just means you got to take the square root of previous answer. So do that, square root of 22.77 or square root previous answer, and you will get little a. And little a should be 4.773, because when you round to 3 decimal places. So there you go. There is little a. Little a, well, right here, is 4.773. Awesome. That was a bit of work. I'm going to go ahead and erase my work for the other two. Now you're probably thinking, do I have to do all that work again and again for the last two? It's probably what you're thinking. It's going to take forever. Let me finish this. Okay. Now that's probably what you're thinking. But wait a minute. Look at what I have now. I have a big A and I have a little a. I have a pair! Yay! And you know what that means. If you have a pair, you can use the law of sine. Music to my ears. The law of sine was so much more fun. So let's do it. All right, so law of sine, since my pair is big A, little a, I know I'm going to have to use the A's in my law of sine. And in this case, since we're finding big B and big C, doesn't matter which one, I'm just going to go ahead and use sine of big B over little b. And let's use that to find big B. All right, plug in the values. So I got to do sine of 100 degrees all over little a, where little a, we just found it to be 4.773. Then I got to do sine of big B, I don't know what big B is, all over little b, where little b is going to be 4. Perfect. Oh, somebody erase that. And once we get to here, you just do what we did in the last video, cross multiply. Across the first way, you'll get 4 times sine of 100 degrees. All that divided by 4.77. Oh, shoot, I didn't mean to do that. Okay, cross multiply, you get 4 times 100. Cross the other way, you'll get 4.773 times sine of big B. Okay, now next, our main objective is we got to get the big B by itself. I'm going to do the easy stuff first and divide by 4.773 to both sides. Okay? So then, that's going to give me over here 4 times sine of 100 degrees. Divide that by 4.773. And that's all it's going to be equal to sine of B. There you go. So now, So now, of course, to get the big B by itself, we now got to get rid of the sign. And the best way to get rid of sign is its inverse. So we got to take sine inverse of both sides. So that will cancel, and all you'll have left on the right is big B. So then all you got to do is figure out what this is, and then take the sine inverse of previous answer. I'm going to go ahead and do that real quick with you guys. So 4 times sine of 100 degrees. And then we're going to divide that by 4.773. Then take the cosine. Oh, no, sine, we're right. Do sine inverse. Sine inverse of previous answer. And you're going to get big B is 55.620 degrees. Rounding 3 decimal places, but you don't have to put that 0 if you don't want to at the end. I'm just going to do it because just out of habit. So there you go. There's your big B. Big B, 55.620 degrees. Nice. Didn't have to use the law of cosines. All right. All that's left now is to find big C. And this, to find big C, is going to be the easiest part because we have 2 angles. And we all know that all 3 angles have to add to 180. So then, if A is 100, and if B is 55.62 or 620, you just got to find the 3rd angle that equals to 180. Same stuff we did yesterday. So then compute that, find the 3rd angle to make 180, and you should get that C is equal to 24.380 or 24.38. The Hawks program should take either or. So there you go. We're basically doing the same thing we did yesterday, finding the 3 remaining sides. This example, we just didn't have a pair to start with, so you had to use the law of cosines to find your pair. And then once you have a pair, you can go back to the law of sines and do what you do. All right. So we'll do another example using the law of cosines, and let's see how we do. Find the remaining angles inside of the triangle. Squeeze it up a little bit. Oh, and some of you are probably realizing something here. Whew. Well, I mean, to start off, you see that, well, there's no pair. And also, you're probably realizing for this example, there's no angle. What? Miss Shulin, you're supposed to have an angle for the law of cosines. How can we solve this? I know someone is saying no solution. I know someone is. Someone always says it. You know who you are. But there is a way to solve it. There is a way to solve it even though you have no angle. But that is our objective. We are given 3 sides, and we need to figure out what those angles are. Angles A, B, or C. So, now you're probably wondering, Miss Shulin, if I don't have an angle, what variant of the law of cosine should I use? Well, let's go back to the previous slide. So yeah, if I have no idea what angle I have, how am I supposed to choose? And your answer? It actually doesn't matter. You can pick any one you want. You just got to use one of them. So, just for skittles and giggles, I'm going to go ahead and use the first one. And we're going to use the first one to help us find angle A. So let's go ahead and use that one. We'll use the first variant of the law of cosines. Okay? Okay, so I'm going to go ahead and write that down. A squared is equal to B squared plus C squared minus 2BC times cosine of big A. Again, I'm just copying down the first variant of the law of cosines. Okay, just gonna double check everything's copied correctly. Good. All right, now let's plug everything in. So I have an A squared this time where my A is 8. So that's gonna be 8 squared equals, I'm gonna go ahead and put my brackets in. Okay. And then my B squared, where my B is 7, is going to be 7 squared. And then C squared, where C is 6, so it's going to be 6 squared. Then subtract that from 2 times B, which is 7, times C, which is 6, times cosine of A. I do not know what A is yet. All right, the numbers are plugged in. Now let's do the chugging. So first, over here, I'm going to have 64. 64 equals, I'm going to get my brackets in. Okay. All right, so 7 squared plus 6 squared. I'm going to go ahead and just compute all that in the calculator. So clear 7 squared plus 6 squared, right? That's going to equal 85 when you do all that. Now I'm going to subtract it from this. I'll go ahead and do 2 times 7 times 6, correct? And that's going to give me 84. And that's still going to be times cosine of big A. Okay. So we can't do any more with the green or the red because we don't have an angle A. So our objective is we're going to try and get A by itself, meaning we got to remove everything else and move it to the left side of the equation. I'm going to go ahead and start with the green bracket. Now for the green bracket, it is a positive 85. And in this case, it's not being multiplied or divided by anything, so you can assume the 85 is being added. So in this case, the positive 85 will be subtracted to both sides to be the opposite operation. So let's go ahead and do that. Subtract 85 to both sides, and you're going to do 64 minus 85. And that's going to give you negative 21 on the left side of the equation. On the right side of the equation, we still have that minus in front of the red bracket. So let's keep that minus there. And then you got everything in red right here. So everything in red, 84 times cosine of big A. And remember, still objective. Our objective is to get the A by itself. All right, we're off to a good start. And technically at this point, since the green bracket is no longer here, we actually don't need the red bracket anymore. Because the whole point of the red bracket was to separate it from the green. But now the green is gone, we don't need it. Whoops, not need to do that. Let me fix that. So we can go ahead and erase the red bracket. Don't erase the minus though. The minus is actually going to turn into a negative now. So instead of minus 84, think of it as it's a negative 84 now. A negative 84 being multiplied to cosine of A. And now, our next objective is we need to get rid of this negative 84. And now, when you're looking at the negative 84, some of you are really tempted, some of you probably really want to add this 84 to both sides. I bet some of you really want to do that. You want to add. Unfortunately, you don't add. Wait, Miss Shulin, what am I supposed to do? Am I supposed to multiply? Am I supposed to subtract? Am I supposed to divide? What am I supposed to do? Well, look at this. The negative 84 is being multiplied, which means to get rid of it, you got to do the opposite of multiply, which is divide. So you're going to have to divide negative 84 to both sides. That is the number one error kids make when solving this. Do not add. Divide, because that's the opposite of multiplication. If you remember that, this should be smooth sailing. All right, so on the left side, you'll do negative 21 divided by negative 84, which should get you 0.25. And then that's going to be equal to cosine of A. So cosine of A. All right, we are almost done. I just got to get rid of that cosine. And you guys know how to do that. Inverse. Take the inverse, cosine inverse of both sides, and that will get big A all by itself. Now you just got to do cosine inverse of 0.25. And make sure it's in degrees. And when it's in degrees, your A should be 75.522 degrees. And there you go. That is your big A. So let's go ahead and write that up here. Big A is 75.522. Done. Whew, that was a bit of work. Well, cosine, it doesn't mess around. You got to be diligent. You got to be slow. You got to make sure you don't make mistakes. Do your math correctly. All right. So now we have an angle. Finally. And check it out. Little a, big A. I have a lovely pair, which means I can do the law of sine. Don't got to do the law of cosine. I can go back to the law of sine. Yeet, yeet. I really got to stop doing the yeeting. I just moving on. Anyway. So now, as I said, we got a pair, so we can use the law of sines. And my pair is A, so I'm going to do sine of A over little b. And it doesn't matter which one we do. I'm going to go ahead and do sine of big B all over little b. Plug in the values. So sine of A, big A, we got to be 75.522. Erase that. Degrees. And then little a, what did we say was little a? Little a was 8. Okay? And then you gotta do sine of big B. We don't know what big B is yet, but we do know little b. Little b we said was 7. Okay. So there you go. And now you just gotta cross multiply and solve for big B. And at this point, you guys know how to do this. This is basically the same stuff from the first video. So I'm going to let you do the rest of the work on your own. And when you get your final answer, you should get that big V should be 57.909 degrees. Again, you guys know how to do the loss lines at that point. Just going to save me time in terms of the video. And that's how you find big B. To find big C, you guys know what to do from here. Because now that we have two angles, we can use 180 to find C. A plus B plus C equals 180. The big A will be 75.522. Big B will be 57.909. Then you just need to figure out what C is to make that add to 180. And again, you guys know how to do that. And you should get that big C should be this. 46.569 degrees. Just going to double check that with my answer key. Yes. So there you go. That's how you solve that one. So again, for this example, if they don't give you an angle, you can choose any variant of the law of cosine to find one of your angles. Then just use the law of sines and the 180 stuff to find the last two angles, and then you're good to go. All right. So now that you're more comfortable with the law of cosine, well, let's jump into some word problems. So for this example, a farmer makes a pen for his chickens in an inside corner of his barn. And the lengths of the sides of this pen are 11 feet, 7 feet, and 12 feet. what are the respective angles in degrees, round to the nearest hundredth. So in other words, this guy's making a rectangular pen, and he gives us the sides. He gives us the first side is 11, the second side is 7, and the third side is 12. Now, just so you know, you don't have to label little a as side 11. If you want to have the side little a be 7 or 12, that's totally okay. The same thing with B and C. It doesn't really matter. So, but just for this example, I'm going to have A be 11, B be 7, and C equals 12. Again, doesn't matter which one's A, B, or C. And sure enough, it's asking what the angles are. We want big A, big B, and big C. So that's what we're going to find. Big A, big B, big C. And you guys are probably recognizing this example is pretty much the same as the previous example. The previous example gave us 3 sides, and we had to find the 3 angles. Same thing here. 3 sides, we got to find the 3 angles. So you literally treat it the same way. So in other words, you can choose any law of cosine equation, first, second, or third, and go from there. It seems like a lot of people just go ahead and always stick to the first one. So I'm going to just go ahead and do the first one then. So a squared equals b squared plus c squared minus 2bc times cosine of big A. And again, just using the respectful brackets around the respective parts. So that's the formula we're going to use. Let's plug everything in. Okay. So first we're going to do a squared. We go ahead and get the brackets up. Good. All right, so first, well, hold up a second. My a squared, my a is 11, so that's going to be 11 squared. B squared will be a 7, that's going to be 7 squared. And then plus c squared, where c squared is 12. And that's going to be minus 2 times b will be a 7, times c, where c is 12. And then, again, multiply that by cosine of 8. All right, we got everything plugged in. Let's do the chugging. Make more space. There we go. So first, let's do 11 squared, which is going to be 121. And then I'm going to go ahead and get the brackets set up again. Good? Okay, I'm going to go ahead and just do 7 squared plus 12 squared. So 7 squared plus 12 squared. That's going to give you 193. Okay? And that's going to be minus the next part. The next part, you'll do 2 times 7 times 12, right? And that's going to give you 168 times cosine of big A. All right. Moving on from there, can't really simplify much more from here. So this is now the part where I have to get A by itself. So I'm going to start with the green bracket and move that to the left side. Here, it is currently a positive 193. And the opposite operation would be to subtract it. So I got to do 121 minus 193. And that's going to equal negative 72. I'm going to do that in red. No, I'm going to do that in black. So negative 72. Everything in green is gone. We just have the minus sign. And then we have everything in the red, which in this case would be 168 times cosine of 8. All right. So now we don't have a green bracket anymore, so we don't really need the red to separate it. So we can go ahead and get rid of the red bracket now. Get rid of it, but don't get rid of the minus. The minus is now going to be a negative. So now it's negative 168. And now from here, again, it is very tempting. It is very tempting to try and add this to both sides. It is extremely tempting. Please don't do it, because that's not the opposite operation. This number is being multiplied, so the opposite operation is division, negative 168. You guys can tell that I've seen a lot of kids do this mistake because of how much I'm emphasizing this. I'm just making sure you do not fall into the same trap. So, divide, and let's see what happens. All right. Here, I got to do negative 72 and divide that by negative 168. And that's going to give me a really, really, really huge decimal. And yes, you're going to have to make sure you use all of it. 0.428571429. Just going to double check that. 428571429. Good. And all of that equal to cosine of big A. All right, almost done. All that's left to do is inverse, so that the cosines will cancel. So cosine inverse to both sides. These will cancel, and then you'll just be left with big A on the right. Now you just got to do cosine inverse of this decimal, or cosine inverse previous answer. So cosine inverse of previous answer, and you should get your big A, which should be 64.623. But wait a minute. Let's check the instructions. The instructions said round to the nearest hundredth. Hundredth means 2 decimal places. So then, in other words, the 3 wouldn't tell us to round up, so it'll just be 64.62 degrees. So let's go ahead and write that for big A. Big A will be 64.62 degrees. All right. Woo! We got the law of cosines done. Woo! Okay, I'm going to erase the work so I can make room for the rest of the work. Okay, awesome. All right, so let's check. Ooh, I got a pair. Big A, little a, which means I can use the law of sine. Don't have to do law of cosine anymore. And then just like before, our pair is A, so I'm going to do sine of A over little a. And for skittles and giggles, I'm going to go ahead and do sine of big B over little b. Plugging in the values, I'm going to have sine of big A, well, big A is 64.62 degrees. Little a, in this case, little a I labeled as 11. Sine of big B, don't have big B yet. Little b, what did I label little b as? Little b was 7. Okay. All right. So then, once you get to here, cross multiply, solve for big B, which you guys already know how to do from part 1. So you guys can go ahead and do the rest from there. Check your answer. And your answer for big B should be 35.09 degrees. Yep. All right. We got all the hard stuff done. Now to find the third angle, little c, you guys know what to do. You know that angle A plus angle B plus angle C is supposed to equal 100. And of course, you already have angles A and B. You just need to plug those in, find big C. And when you do that, when you solve for big C, you should get 80.29 degrees. And now, just want to let you know, for this example, it doesn't matter what angles you label A, B, and C. It specifically just wants your 3 answers. Doesn't matter what order. Like for example, for this problem, the Hawks program is going to give you 3 boxes. So box 1, comma box 2, comma box 3. And in these 3 boxes, you just put your 3 angles. Doesn't matter what order. Like for example, I can put angle C in the second box with the degree symbol. I can put angle B in the first box. So 35.09. And then I can put angle A in the third box. Again, doesn't matter the order as long as you have those 3 angles. Just going to give you a heads up on that. Doesn't matter which one's A, B, and C. As long as you have all 3 angles, you're good. Cool. All right, so that takes care of that example. One more word problem to talk about. So for this one, I kind of went already ahead and doodled this one to give you a visual of what's happening. So a toy boat is seen floating down a river. The toy boat is first spotted 85 feet away. 8 minutes later, the toy boat is 35 minutes away, making a 50-degree angle between the 2 sightings. Given this information, how far did the boat travel? All right, so let's first visualize and break down all the information we have. And once we do that, then we can focus on, well, what we're trying to solve. I had to get a drink of water. Hello, hello, hello. My bottle has an echo. Anyway, so let's first look at the first piece of information we have. We have a toy boat is first spotted 85 feet away. So in other words, let's say this person's just lounging by the riverside, and let's say, oh, he sees a boat. So in other words, this is where he first sees the boat. And he currently deduces that this boat is 85 feet away. I seriously have no idea how he found out that he has 85 feet, that the boat is 85 feet away. I'm guessing he has an app or something. He's either that or he's one smart cookie. Anyway, so in other words, from him to the boat, from when he first sees it, is 85 feet away. Okay, so now 8 minutes later, the boat is then seen 35 feet away, making a 50-degree angle between the 2 rivers. So in other words, what's happening here is basically after the first spotting, the boy is going to keep watching the boat as it floats down the river. And let's say 8 minutes have passed. And after 8 minutes have passed, the boat is now closer to him. And he deduces that the boat is now 35 feet away. And also, we are given that we have a 50-degree angle between the 2 sightings. So in other words, if this is the first sighting, this is the second sighting, apparently that means that from sighting 1 to sighting 2, that was a 50-degree angle between the 2 sightings. Again, how can this kid deduce this? How can he deduce 85 feet, 35 feet, and 50-degree angle between the 2 sightings? That must be some really nice app. I need to figure out what this app is, whatever name it's called. But anyway, that's all the information we have. And while we're at it, I'm going to go ahead and just for simplicity's sake, I'm going to label stuff. Because it looks like, if you look at all the green parts, it looks like we have a triangle. All right, so I'm going to label this side little a, I'm going to label this side little b, and I'm going to label this side little c. And we do not know what little c is. And if this is little c, that means the angle I have, or the opposite angle, that has to be big C. Because again, big C and little c have to be opposite of each other. So now, given this 2 information, now we can ask ourselves the question, how far did the boat travel? Or in other words, from the first sighting to the second sighting, how far did the boat float? We know it took 8 minutes. That's the time, but we want to know distance. Or in other words, we want to find side C. We want to find how many feet that is between the two boat sidings. So that's our goal. We need to find little c. Well, I guess I can start to see if I can use the law of sines. Let's see here. Do I have a pair of big A's and little A's? Well, I got a little a, but no big A. What about big B and little b? I got little b, but I don't got big B, so I can't use that. What about big C and little c? Well, I got big C, and little c is what I'm trying to find. So that means I can't use that. So law of sines is a no-go. That means I got to use the law of cosine. Which law of cosine should I use? Well, which law of cosine uses angle C? If you look back to that little law of cosines chart, you'll see that the third variant of the law of cosines is what we want, because the third equation has angle C. So let's go ahead and just copy down that law of cosines. Let's copy that third equation down. The third equation, double check me on this, c squared, make a little more space. Oop. Okay, c squared equals a squared plus b squared minus 2ab times cosine of big C. Double check that. Just make sure that is the third equation, or the third equation for law of cosines. C squared a plus b squared plus b squared 2ac cosine of big C. Okay, so that's the one we're going to use because we have angle C, and that will be more useful to us. All right, so now let's plug in the values. C squared, we do not know that yet. I'm going to go ahead and draw in my brackets. I just realized I used the wrong color. Oh, that's going to annoy me. Let me fix that. Sorry about that. That was just going to annoy me. I'm a little OCD. Green, red. There we go. We're good. We're good now. Okay, back to business. Green, red. Okay. Okay, so first, I need a squared. What did I label as a? Or little a? Little a is 85. So that's going to be 85 squared. Then plus b squared. What did I label as b? Little b was 35. 35 squared. And then subtract that from 2 times a. A was 85. And I realized that's supposed to be a b. There we go. So 2 times a times b. And then b is going to be 35 times cosine of big C. What was big C? Big C was 50 degrees. All right, 50 degrees. Okay. Okay, sorry for the typos on that. We should be good now. We got everything that needs to be plugged in. Now we can do the chugging. All right, so C squared. Let's get the brackets up. Okay. All right, we're going to be dealing with some bigger numbers this time. It's going to be fun. Okay, so let's do 85 squared plus 35 squared. And that's going to give you 8450. Looks good. 8450. That's what you get when you do 85 squared plus 35 squared. Okay, moving on to the next part. And now I got to do 2 times 85 times 35. So 2 times 85 times 35. Oh, shoot. I did the wrong thing. So 2 times 85 times 35. Got it? That should give me 5950 times cosine of 50 degrees. All right. Continue from here. we've already simplified everything in green. Now we can simplify everything in red. We can do 5950 times cosine of 50 degrees. So 5950 times cosine of 50 degrees. And that's going to give me a big decimal. And yes, you got to use the whole decimal. 3824.5, shoot, 0.58627 8. 3824.58627 8. Perfect. All right, we're almost done. Next thing we got to do, you got to do everything in green minus everything in red. And if you want, you could do 8450 minus your previous answer. So that should make it easier for you. So 8450 minus previous answer. That's going to give you this. It's going to give you 4. Let me write that a little bit lower. C squared equals 4625.41372. Great. Awesome. All right, we're almost done. We got to solve for little c. We got to get rid of this power 2. So now I got to take the square root. And you can just do square root of previous answer. It'll make it much easier for you. So square root of previous answer. And that's going to give you that little c is 68.010. In this case, it'll be feet. And that's little c. And lucky for us, little c is what we've been trying to find in the first place. We were trying to find the distance from the first boat sighting to the second boat sighting. So there you go. That's your answer. Your answer is going to be 68.010 feet. And technically you don't have to write that 0 at the end. So if you want, you can just do 68.01 feet. Now, I don't know if the Hawks program wants you to round to the nearest foot, or if it wants you to round to 2 or 3 decimal places. I forgot to check on that. Just make sure you read the instructions carefully when you have your answer for this. Look up how many decimal places you have to round to. And for this example, that's all we really have to find. We don't need to find the other 2 angles because the instructions only wanted how far the boat was going to travel. That's all it wanted. It didn't want the angles. So we're done. We don't got to do any more. And just so you know, this is actually the typical type of problem that you would see on the ACT because it uses the law of cosines. Something else is that this is a typical type of problem you'll probably see on a college entry math test. So for any of you who are applying to Rolla for college, this is the type of problem you'll most likely see if you have to take a entry test for them to see where you need to go for your math classes. So just want to point that out. So now the last example, very similar. It's basically the exact same problem, only this time it's a canoe. And also the spottings have different distance. The first spotting was 75 feet. The second spotting was 10 feet. The angle between them is 65. Basically, go ahead and try this one on your own, doing the exact same stuff. So go ahead, pause the video, and try it yourself. Okay, you should have had, if you want to check your answer real quick, you should have resumed the video by now. So if you checked your answer, the distance between canoe, the first sighting and the second sighting for the canoe, your distance between those 2 sightings should be this. It should be 68.972 feet. And again, I'm just rounding the 3 decimal places just in case. If you rounded to 1 or 2, or if you rounded upward to 69 feet, that's totally up to you. Or it's up to the Hawks program. But I'm not going to work through this one. I think you guys basically got the law of cosines underway. If you need to double check if you didn't get this problem, look at the previous problem and just watch the steps that I did and go from there to see what your mistake was. So, with that said, you are basically ready for the online homework. You know how to do the law of sines, you know how to do the law of cosines. You are good to go for the online homework. If you have any questions, feel free to email me, or we can do Google Hangouts if you need to talk to me one-to-one. And with that said, I bid you all adieu.